Good morning, class. All right, we'll be starting a new topic today. In continuation of our skill. We'll be starting a new topic today. And as trigonometry. Everybody say that? Trigonometry. I heard someone pronounce it as trigonometry, because it can still be correct, but the correct pronunciation is trigonometry. So the tree, that's the tri, T-R-I, there, of course, see, it represents three. That's tri, like in terms of triangle. So the gono is the side, that's three sides. Then we have metry. Metry is the measurement. So measurement of what? Triangle. So trigonometry studies the relationship between sides of triangle and what? And its angle. Sides of triangle and its what? Angle. That is trigonometry. Now, it is so much applicable in real life. You apply it in engineering. For those of you that have done simple harmonic motions, that's trigonometry. And that is why you have the velocity as amplitude sine omega t. You can see that sine, as we'll be discussing later, is one of the ratio of trigonometry. So it's so much applicable in engineering, construction, in circuit building, that's in computer engineering. Also applicable drawing. You apply trigonometry in construction of angles. Astronomers use it too in heavenly bodies to get the distance between the planets. They also make use of trigonometry. So it's very, very applicable to the real world. But we'll not be looking at the application. What you need now is to kickstart and then start working with trigonometry. As time goes on, you can apply it to your various fields. So we are going to be looking on the basic trigonometric ratio. On the basic what? Trigonometric ratio. Then after that, we look at their reciprocals. The reciprocals, then we talk about identity. So we are going to be proving a whole lot of identities. I want you to pay keen attention as we move on. Are we good? Okay, write down. Trigonometry is a branch of mathematics. Trigonometry is a branch of maths. Anthony, you are not writing. A branch of mathematics, write something down, that studies the relationship. Between the sides and angles of a triangle. The sides and angles of what? Of a triangle. So you can see we're focusing majorly on a triangle. So that we can see there are different branches in trigonometry, but we'll focus on plane trigonometry. Because we have plane trigonometry, we have spherical trigonometry. That's when you want to talk about the 3D part. But we are going to focus on the plane part. And on the plane part, we are going to be discussing more about right-angled triangle. We're going to be discussing more about what? Right-angled triangle. I believe you know what right-angled triangle is. When you have this triangle, this is a right-angled triangle. So we're going to discuss more about this. Are we good? Alright, let's look at the basic trigonometric ratios. Basic trigonometric ratios. We have three basic trigonometric ratios. Every student should remember that. If they should tap you and wake you from your sleep, you should be able to tell us these are the ratios we have in trigonometry, and you should be able to explain them. So the first one is what? Sine. The first one is what? Sine. So from your idea of so we have sine, cosine, and tangent. We have what?
Sine, cosine, and tangent.
So we can define these three ratios based on a right-angled triangle. So let's consider this right-angled triangle. Right? Consider a right-angled triangle. Because let's name it ABC. So if we have a right-angled triangle ABC, this is our triangle, a right angle. So this is indicating that this is a right angle. So if we have a right angle, of course, let's name it ABC. The naming convention should be clockwise direction. But if you choose to name your own anti-clockwise, it is still correct. But professionally, it's good to name it like this, ABC. Now, if this is angle B, you can see it's written in capital letter. That means this will be side B. That does not mean you cannot use any other variable to represent that side. Then this is what? This length is side C. Why this length is what? Side what? A. So you can still call it length CB, AB, and all that, but we'll just give it a name like this. Are we good?
Yes, sir.
Now, if you have a right-angled triangle, there is a name this line is called. What is that name? Very good. So this is our hypotenuse, and this is called what? This is called what? This is called what? This is called what? So why is this one opposite? There is no angle stated here, so we don't have what? Opposite. But if I should state an angle, let me call that angle. Let me use a variable theta to represent that angle. Then I can boldly call this one what? Opposite to the angle theta. Why this one is what? Adjacent. Are we together now? So with this, we can define these three basic ratios. So the first one, that's from SOHCAHTOA. Everybody did this now. From SOHCAHTOA, the first ratio is what? Sine theta. That is sine of this angle. Now I want you to note here that sine theta is not the same thing as sine times theta. It is not the same. They are not the same. Hope you've noted that. Just like you have this. Now A sine omega t, you can say this is the same as A times sine omega t. So the angular velocity and time, they are angle inside the ratio sine. You can't separate them. Are we together now? So sine theta here, based from this SOHCAHTOA, you can see OH is what? Opposite over hypotenuse. So I can write this as opposite over. This is what you should remember, and you must remember this for you to be able to work with us. Are we good now? So if I compare it to this triangle now, my opposite is what? My opposite is what? My opposite is what? B, and my hypotenuse is what? C. So we can say that sine theta from this triangle is B over what? B over what? Then the second one is cosine. Cos theta is what? Adjacent over hypotenuse. Ore, are you here? So adjacent over hypotenuse. Adjacent over hypotenuse. Now, what is our adjacent? Yomade, what is our adjacent? Speak up, speak up, speak up. What's our adjacent? In Matthew, what's our adjacent? Very good. Our adjacent is A. Yomade, you are not here. Our adjacent is A. So we have A over. Yomade, what's the hypotenuse? Speak up. Speak up. C. So that's A over what? C. Are we good now? Then the third one is tangent. That's tan of the angle theta. So tan is what? Tan is what?
Opposite.
Over. Very good. So that's opposite over adjacent. So our opposite here is what?
B over A. B over A.
So we have B over what?
A.
Now, I want you to note here, note that this tan theta can also be defined as the ratio of sine and cosine. Sine theta over what? Cos theta. Yes. How? How can it be defined as this? Now let's check. If sine theta is b over c and cos theta is a over c, so we can write this as b over c over a over c. Remember what I taught you? Close, close, far, far. So you can say this is bc over ac. So this will go with this. We still get our over a, which is tan theta. So we should agree and say it boldly or write it boldly that tan theta is the same thing as what? Sin theta over cos theta. Are we good?
Yes, sir.
Alright. Quickly jot that. Moving on now, let's look at the reciprocals of these ratios. The reciprocals of these ratios. Someone get me a duster. Okay, thank you. Thank you. Alright, let's look at the reciprocals of this identity. Can you see it here? Can you see it here? Should I write it here?
No.
Okay, let me move closer. This place is better, right?
Yes, sir.
Alright, now let's look at the reciprocals. Reciprocals of trigonometric ratios. So when we say reciprocal, what do we mean? Simply put 1 over. So I don't want to call it inverse. Because if you have something like this, if you have 1 over sine theta, for instance, hope you know that it is not the same thing as sine inverse of theta.
Yes.
Hope you know that this is not the same as this. So if you don't know before, you have to notice that this is not the same thing as what? This. So this is the reciprocal, while this is what? Inverse. This one, you're asking for the angle that will give you the result. Let me say sine inverse of 1, or let me say sine theta equal to 1. So if I want to find theta in this case, I will have to find the sine inverse of what? 1. And that is what? 90. But that means theta in this case is 90, but it's different from this. Hope you've noted that.
Yes, sir.
Now, the first reciprocal is that of sine theta. So if I have 1 over sine theta, 1 over sine theta is defined as cosec. Cosec what? Theta. Cosecant is defined as what? That's cosec theta. So it's not like you have co-separate now sec. No. Cosecant is a ratio on its own. Are we good? So you just look at the third letter. The third letter here is S. So you know that it's 1 over S. For those of you that would like to memorize, of course, it's still advisable to do that. But it's good you understand what we are doing. Then that means I can write this as what? The reciprocal of this should be what? Hypotenuse over opposite. Then the second one is what? That of cosine. So we have cosine is secant. The reciprocal is what? Secant. So you pronounce it as sec theta. So that is 1 over what? Cos theta. So the reciprocal of this will now be what? Hypotenuse over adjacent. Are we good?
Yes, sir.
Why the third one? The third one is cotangent. That's cos theta. So the reciprocal is 1 over tan theta. So if you find the reciprocal of this, that will be what? Adjacent over what?
Opposite.
Very good. Over opposite. Are we good? So everybody should be able to know states the 3 basic ratios. Tell us sin theta is this, cos theta is this, tan theta is this. They are reciprocals. You state this. Cosec is 1 over sine. Sec is what? And cot is what? 1 over tan. Are we good?
Yes, sir.
Okay, moving on. Write that quickly. Moving on. Now, let's look at 3 basic identities you must remember in trigonometry. If you are talking about trigonometry, you must remember these 3 basic identities. Why are they called identities? Or better still, what is the difference between identities, equation, and function? Identities in maths, equation, and function. So, is there anybody that can differentiate and tell me maybe a difference between these three? Identities, equations, and functions. Who can differentiate it? Identities. Okay. If we have, let's say we have 2x plus 1 equals to 0. This is an equation, right?
Yes, sir.
What type of equation is this? Linear equation. Very good. Why is it linear? Because of the degree of this form of this equation. That's one. So it is not linear. So it is only one value of x that will satisfy this condition. If it is linear, if it is quadratic, you have 2 values. If it is cubic, you have 3 values. Because it is an equation, only one value of x, and that is minus 1 over 2. There is no other value. Are we good? But if you now have identity, let's say sine x, sine squared x plus cos squared x equal to 1. We have infinite values of x that will satisfy this condition. If you put x as 0, it will still give you 1. Put x as 2, still get 1. Put x as 90, your answer will still be what? 1. So that is why this is called an identity. That's just a slight difference between the two. Why functions are just rule. If I have f of x equals to 2x plus 1. So this is a function that takes value from x. And those values are called what? Domain. So this is just a rule to get maybe your range. If you have an input, there should be an output. If there's an input 1, then it will result to an output 3. If there's an input 2, there's an output what? 5. So those inputs are called domain, while output are called what? Codomain or range. So that's just the difference. Now let's look at the basic trigonometric identities. Basic trigonometric identities. So we have 3 of them, just like I've stated before. The first one is that whenever you have sine squared of any angle plus cos squared of any angle, the result is what? 1. The result is what? 1. Then I still want you to note here that this sine squared theta, you know, theta is an angle inside, you can't separate both of them. It's not the same thing as sine theta all squared. They are not what? The same. No, they are not the same. But you can see that your sine squared theta is the same thing as sine theta all squared. Are we good? So I want you to note that as we move on. Now, how is sine squared theta plus cos squared theta 1? Let's quickly prove that with what we have on the board. To prove that sine squared theta plus cos squared theta is 1, we just use this. Pick sine theta, we have agreed that sine theta is what? B over C, then square it. Plus cos theta is what? A over C, square it. So if you square it, the square goes for both the numerator and the denominator, right?
Yes.
So I can write as b squared over c squared plus a squared over what? C squared. Then I will do what? Find the least common multiple. So what's the LCM? C squared. Right? So c squared divided by c squared. C squared divided by c squared. 1 times this. So we have b squared here plus c squared divided by c squared. 1 times this.
A squared.
Very good. A squared. Here comes the problem. So what is b squared plus a squared? Is what? Very good. How is it c squared? If you look at our triangle, thank you, Caleb, from Pythagoras, so this apostrophe should be there. You can say Pythagoras or Pythagorean. From Pythagoras theorem, We know that hypotenuse squared equal to what? Opposite squared plus what? Plus what? So we know that our hypotenuse here is C. And opposite is what? B. Adjacent is what? So I can say that my hypotenuse, let me write this out, equals to adjacent squared plus opposite squared. So I can say that C squared, what's my adjacent there? A squared plus what? B squared. So instead of writing this B squared plus A squared, which is the same thing as A squared plus A squared, I can write this as what? C squared over what? C squared. And what is C squared over C squared? 1. That means sine squared theta plus cos squared theta is what? 1. Any problem with that? Now let's look at the second identity you must remember. So the first one is what? Sine squared theta plus cosine squared theta equals to 1. So that means someone can just think. You now say, oh, so sine squared theta plus cos squared theta. That means sine squared theta is 1 minus cos squared theta. Is it not correct? Very correct. So that one, you can still form any other identity you want. Now, the second one will be obtained from this. Let me call this first one equation 1. To get the second one, let me divide 1 by, let me divide by sine squared theta. Let me divide by sine squared what? Theta. So if I divide by sine squared theta, I will have sine squared theta over sine squared theta plus what? Cos squared theta over sine squared theta equal to what? 1 over sine squared theta. Are we good? Now, what is sine squared theta divided by sine squared theta? 1. Very good. That is 1. Plus, now who can tell me? What is cos squared theta divided by sine squared theta?
Inverse of
Inverse of what? So what is not in say reciprocal? Of what? Tan squared theta. So what is that cos? Cos. So that is cos theta. So because of the square, I can call this cos squared theta. Are we good?
Yes, sir.
Equal to what is 1 over sine squared theta? That is what? Very good. Look at it. Cosec theta is this. That means the square of it is still the same thing as what? Cosec squared theta. So that is the second one. That 1 plus cos squared theta will give us what? We give us what? Thank you. That's cosec squared theta. Sorry for that. So 1 plus cos squared theta is what? Cosec squared theta. Are we good?
Yes, sir.
Now the third one will be obtained when we divide equation 1 by what? Cos squared theta. And let's divide through and see what we'll get. We have sine squared theta over what? Cos squared theta plus cos squared theta over what? Cos squared theta equal to what? 1 over cos squared theta. We are dividing through by what? Cos squared theta. Can you see the bond?
Yes, sir.
So only sine squared theta divided by cos squared theta. What's the result? Tan squared theta. Why is it tan squared theta? Initially, if you remember, I told you that tan theta equal to what? Sine theta over cos theta. Did I tell you that? So that means tan squared theta, like Caleb has rightly said, is the same thing as sine squared theta over what? Cos squared theta. So this will become what? Tan squared theta. Plus cos squared theta divided by cos squared theta is what? Is what? 1. Because this will kill this. That's all. So we have 1 here. Then 1 divided by cos squared theta. Emmanuel. Emmanuel, are you sleeping?
Squared theta.
What's the result? 1 over cos squared theta is what? Before, don't waste our time. You are not seeing it clearly. Use your inner eye. So 1 over cos theta here, look at it, is sec theta. That means 1 over cos square theta will be what?
Sec square
theta.
theta.
So that is the third one. So what are the three basic identities? Sin square theta plus cos square theta is what?
1 plus cos square theta equals to cosec square theta. Tan square theta plus 1 is equals to sec square theta.
Very good. That's good. Now that means someone can say cosec square theta minus cos square theta is what?
1.
Someone can say sec square theta minus tan square theta is what?
1.
That is it. Very good. That's very good.